Assalamualaikum warahmatullahi wabarakatuh. My name is Amnifiza binti Muhammad Suhaimi and matrix number is 2312928888. Today I would like to do my lab 4, which is root locus. Okay, for question 3.1.1, I typed this coding, which is numerator is 1 and denominator 351. So the G is referred to my system, which is in this question is GS. So I wrote the G equals to transfer function for numerator and denominator. So roots number and roots numerator and roots denominator is referred to I want to find how many poles and zeros in my graph. So root locus for numerator and denominator, which is I want to find the root locus in my graph. So I run. So this is my answer, which is in this graph have a two poles and no zero at this graph, and have a two infinite zero, which is here we can see two different color, which is blue and green. It is referred to two infinity zeros. So this is my answer, which is empty matrix 0 by 1, and my answer is negative 1.4343 and negative 0.2324. Okay, next for question 3.1.2, I wrote this coding, which is numerator is 5, denominator is 1351, and the G is the same as a previous question, which is G is for my system is GS equals to transfer function for numerator and denominator, and then roots number and roots denominator, and then R locus for numerator and denominator. So here I run, and then is my answer for the graph. And in this graph have a three poles, which is 1, 2, 3, and no zeros. So here is don't have a zeros in this graph, and here have a three infinite zero, which is 1, 2, and 3. So for my answer is empty matrix is 0 by 1, and my answer is negative 1.3855 plus 1.5639J, and negative 1.3855 minus 1.5639J, and the last one is negative 0.2291 plus 0.0000I/OJ. Okay, next is for question 3.1.3, which is my numerator is 161 and denominator is 1351, and here is the same as a previous question. The G is my system equals to transfer function for numerator and denominator roots numerator, roots denominator, and the R locus for numerator and denominator. Here I run my coding, and then this is my graph, which is here have a 3 poles, 1, 2, 3, and 2 zeros, 1 and 2. So here have a 2 infinity zeros, which is 1 and 2. So here is my answer for 3.1.3, which is answer for empathy matrix is negative 5.8284 and negative 0.1016, and my answer is negative 1.3855 plus 1.5639i and negative 1.3855 minus 1.5639i and negative 0.2291 plus 0.0000i. Okay, here we will continue for question 3.2.1, which is my coding for numerator is 1 and denominator is 351, and we want to find the root locus for numerator and denominator. Okay, so here I type for the coding to find the k and the poles. So for this question, k is equals to 0. So I try to put my point here. So I select the point at negative 1.4278 minus 0.0020i, and my k is 0.0245, which is k equals to 0. So my poles negative 1.4275 and negative 0.2391. Okay, next for question 3.2.2, my numerator is 1, denominator is 351, and then here is the same as the previous question, because we want to find the k and the poles. So I run this coding and I select add here, and I got the answer is for selected point is negative 0.8347 minus 0.0020i, and the value of k I got 1.0833. Also, and the poles is I got negative 0.8333 plus 0.0015i and negative 0.8333 minus 0.0015i, which is as we increase the value of k, the poles move toward each other. So here we found the breakaway points where they meet before becoming complex. For question 3.2.3, my numerator is 3 and denominator is 3421, and then we want to find the k and the poles. So here our locus is the same coding as a previous question. So after I run, I got this graph, and this is my result, which is I put here. So my selected point is negative 1.1619 minus 0.0199 J, and my K is 0.2115, and my poles have a 3, which is negative 1.1629 plus 0.0000I, and second is negative 0.0852 plus 0.6791I, and here is the same, but here is a minus, here is a plus, and here is minus. So in this stage, the poles enter the complex plane, which means the system will not exhibit an oscillator response. So next is for question 3.2.4, and my numerator is 6, denominator is 1283, and here is the same as the previous question. So I already run, and then this is my graph. So I select the point here. So at 0.0102 plus 2.8080 I, and my value of K is 2.1560, and I have a 3 poles, which is negative 0.0027 plus 2.8265 I, and here is the same, but it's a different here is minus, and is plus, and number 3 is negative 1.9947 plus 0.0000 I. So in by using our log find here in this coding, we defined the exact gain K equals to 2.13, where the poles cross the imaginary axis. Here. This is the critical point before the system becomes unstable in the right half plane. So that's it from me. Thank you.